It's my honor today to present this paper, Perceived Fairness in Free Allocations of Indivisible Goods in Representation of the Authors. It's unfortunate that they cannot come today in person. So, okay, let's get started. So, in this paper, we're looking to the problem like what makes an allocation good. So a good allocation could be like equitable, which means it shares like same amount of items to all the agents. And a good allocation could satisfy the preferences of the agents, and also there are more notions of fairnesses and other things to make an allocation good. Like briefly speaking, like the goodness of an allocation can be divided into efficiency and fairness. In the previous theory paper, they developed different like notions of efficiency and fairness notions, like prior optimalities and MV-frees and more. And then in the practice or the practical aspects, questions proposes like whether these notions of fairness or efficiency do really, people do really recognize them and do behave as they suggested. So in this paper, we will focus on the MV-freeness as a fairness notion and look into the question like, how do people perceive this fairness notion? So let's start on introducing MV-freeness. So in this example, as we can see, the red agents are assigned 3 red ice creams and blue agent 3 blue ice creams. Then in the red agent's perspective, she preferred the red ice cream towards the blue ice cream. So she valued the red bundle, her own bundle, more than the blue bundle. And similarly, the blue agents will value the blue bundle more than the red bundle. In this case, everyone is happy, everyone does not envy the other one's bundle. So this is an MV-free allocation. So MV-freeness is a very good notion because it's intuitive, everyone goes happy, and that it's happy on their own perspective. But the drawbacks is it does not always exist, and it's even computationally hard to determine whether an MV-free exists in the instance. So people develop different kinds of approximations, of which the most important or the most famous one is EF1, MV-free except one goods. So in general, EF1 just works as when doing every pairwise comparison, eliminate one item from the bundle. So in this case, when comparing with the blue bundle, after one red ice cream is eliminated, the red agents will not envy the blue bundle anymore. And similarly for the blue agents. So in this case, we say this allocation is MV-free after one good. But however, as we can see here, so EF1 allocation is actually counterfactual in the sense that it requires agents to hypothetically remove one items in the pairwise comparison. So the envy still exists, but just like the notion requires people to remove items. So another notion we look into is MV-free after K hidden goods, abbreviated as HEFK. So it's a different notion, like it's an epistemic notion of approximating MV-freeness in the sense that, so in the allocation, there are K items being hidden. So, and the hidden item will not be known by the agents, like does not get these items. Only the agents who have received a hidden item knows where does this item goes. So also like look at this example, suppose like the middle 2 ice creams are hidden in the bundle. So after the allocation, the perception of the red agent is actually, so her own bundle is 1 red and 2 blue ice creams, and the red bundle is 1 red and 1 blue ice cream. So in this case, in the perception of the red agents, she will not envy the blue bundle. And similarly, in the perception of the blue agents, she will not envy the red bundle. So this is HEF allocation, where like 2 items are hidden, K equals to 2. Theoretically, like HEFK is a finer approximation of the MV-freeness than EF1, because like we have a more finer hierarchical K, which goes from 0, which is EF1, to a larger thing. But on the other hand, it's kind of sacrificed the information transparency because agents does not know the full allocation of the items. So we were like interested in whether this kind of information loss will affect whether people perceive this as a fairness notion. So in this paper, what we designed a novel framework of perceived fairness. We measure the perception of agents of fairness towards different notions. And also an experiment is conducted on Amazon and Turks, like testing people's perceived fairness towards EF1 and HEFK. And in one word, actually people thinks that HEF allocations are fairer than EF1 allocations. So the survey design is as follows. So as we can see, there are 360 participants. They're divided into 3 different treatments. Each treatment is actually related to a different notion of fairness. And every 8 participants is required to answer like 12 gamified pirate adventure scenarios in which they decide like whether allocation is fair or not. And we will collect all the reports and do the statistical analysis on all the scenarios together, and also on the control of different variables, which we'll mention later. So this is what the survey look like to participant. So the top bar here is the list of all the items to be allocated, and also the subjective valuation of each item to the participant. And the middle chest are the allocations. The left chest is the participants bundle, so what will you will get, and the right are the bundles of other pirates. We also help the participants to calculate the value of each bundle, the participants perceived. And finally, the bottom is the choice for the participants to be made as to whether to swap to a different bundle with a different pirate, or not swap and keep the current bundle. And the key is using the swap rate as a proxy of the perceived envy and perceived fairness. So for instance, if we see like more participants choose to swap, which means it has a higher swap rate, we will perceive this, or we will think this scenario as more unfair. So the workflow of the participants is as follows. First, they will be randomly assigned to one of the treatments, each related to a different notion of fairness. And then each participants go through the tutorial and learn how to play the game. And then they go over 7 small scenarios and together with a feedback question, and then another 5 larger scenarios with another round of feedback questions. So this is the data features of the allocations we use in the pirate games. So there are in general 3 dimensions we look into. So first, the instance. So there are small allocations with 3 pirates, including the participants, and larger with 5 pirates. And also there are balanced and unbalanced allocation. So balance here means like every pirate gets like literally the same number of items, and unbalanced, which means someone gets more items than others. And finally, there is swap is opt, which means like in some of the scenarios, the best choice of the participant is to swap to a different pirates, while in others, the best strategy is to keep the current bundle. So another thing worth mentioning is that in the HEF scenarios, the agents can actually possibly not perceive the allocation of all the items. So if you see the right figure, you will notice that the second item, the blue necklace, cannot be perceived by the participants. The participants will know that this item is allocated to some other pirates, but will not know who gets the item. Okay, so here it comes to the results. So our results shows like the allocations that are visibly envy-free, which is HEFK allocations, are perceived to be fairer than the allocation requires counterfactual reasoning, which is EF1 allocations. So as we can show these bars, so the swap rate of the EF1 allocations are much higher than those of the HEFK allocations, even like there are 2 of 9 items being hidden. And also the similar results will work for different controlling of the variables we mentioned in the data feature. So for example, in this case, which is a swap with opt, in this case, which like in the EF1, which everyone just observed that swap is opt, literally anyone just decide to change. While in the HEF allocations, like at least half of them just keep their own items, which means they perceive these scenarios to be kind of fair. And also we test the cognitive burdens of designing different scenarios. It is proxied by the first response time for scenarios. And also agents are subjectively report their difficulties towards scenarios. And as we can see in these figures, so HEFK allocations have both higher response time and higher reported difficulty than the EF1 scenarios. Okay, so let's make a conclusion here. The contribution of this paper can be threefold. So first, there's an experiment like concluding that HEFK allocations are perceived fair than the EF1 allocations. And also there's a novel testing framework of what is perceived fairness is in the proxy of perceived envy and swap rates. And finally, the data we collect itself can be also a contribution, which it will be released later. And the future direction of this paper will be related to first determine the sensitivity of the perceived fairness related to the number of agents, to the number of goods, and also to the framing, which is how the problem being asked. And also it might be interesting to compare like different notions of fairness, intrapersonal and interpersonal, in this perceived fairness allocations framework. Okay, that's all for today. Thank you very much.